Okay, yeah, so as Arun said, my name is Patrick Whelan. I'm an engineer. And I'd like to talk a little bit about our ARC framework. So the ARC framework is basically a Kotlin AI framework allowing us or enabling us to build LLM-powered agents. It's Kotlin-based, and it's open source. So if you do want to do one good thing today, please go onto GitHub and give us a star. We always appreciate that. At its core, what we have here, what we think makes it special, is this kind of like agent DSL that I think Arun just mentioned. It's basically a domain-specific language designed specifically to help us create these agents efficiently and effectively. But okay, so this is an AI platform. How does this relate to LMOS? So if you consider LMOS to be the operating system, ARC is a framework you can use to build the agents that you can host within this OS system. But okay, so if you go into the internet, you'll get this page here, and you'll see here my first agent in 5 minutes. If you click on this, what we're currently recommending is we have a Spring Boot starter that you can just simply check out and start creating agents immediately. Now, the framework itself is not reliant on Spring Boot. Spring Boot is obviously very popular, but you can use it with any kind of JVM-based or Kotlin-based application framework. So once you've checked it out, what you'll basically end up with is what you see here. So I hope you can see this, but on the left side, it's not really that interesting. It's just basically a standard Spring Boot application structure. We have our Gradle files, we have our source files, and so on and so on. But really all we're interested in is this one folder up here, the agents folder. Everything else is standard boilerplate code you don't need to touch. You may need to configure the model you want to use in the application properties, but otherwise all the magic is happening here within this agents folder. You can have multiple agents within this folder, and we're just going to take a look now at this assistant agent. So an assistant agent here, even if you're not familiar with Kotlin, you should be able to understand that this is an agent. It has a name, assistant agent. It is using the model, the 4.0 model. It has a description, and it has at its heart a system prompt. So if you know anything about LLMs, you know that they like their prompting. And a system prompt is just a certain type of prompt to enable you to give instructions to your LLM model. Now, as you can see here, we have something that is, on the one hand, quite static, but yet there's still some dynamic elements here within the prompt. So in this case, for example, from the agent request, we're getting the user name, and we're telling the LLM to always refer to the user by their name. So in a lot of frameworks, you'll see these prompts being static. But here, we really get the power of allowing some kind of like dynamic elements to it. Because basically, this entire prompt is dynamically created on every single request, allowing us to tailor the prompt for each user. And this is particularly helpful for us because we have multiple netcodes. I don't know if Arun mentioned this, but we've launched our bot here in Germany, in Austria, in Croatia. We want to have one system for all these different netcodes. That's only possible with the power of this kind of flexibility. And what also may not be quite apparent is that even these blocks, even the model we assign to it is also dynamic. I can come in here and I can write an if statement and maybe choose a different model for a different netcode or a different request. So the whole thing is basically built dynamic, giving us the power that we kind of like require. Okay, so now we've created this agent, and as you can see here, it is a fairly normal prompt. We like to give our agents a goal. We like to give the agents some instructions. And down here, you can see the use case it is going to handle. So it says when a customer knows something about AI, then he should go to the register. Great page for AI information. So now how can I test this? So one of the important things that we've learned is that tooling is vital when creating AI agents. You're going to spend most of your time prompt engineering. Building the code and stuff is pretty more just a side effect. So what we've created, once you've started your application, can you see that? Yeah. Once you've started your application as a normal Spring Boot application, you can simply go to the local host 8080 chat index, and you will have access to our test UI. So this is obviously nothing we put in production, but allows you to simply test your agent locally. And here you can simply go in and ask a question. So as you can see, it's providing the answer that we required. On the right-hand side, you can see some of the events that are fired by the agents. Inventing is very important to understand how our agent works. So for example, I can go in here and I can take a look at the prompt. So you can see here that this line here is missing. I didn't provide it a username. And this is the final prompt that was generated and passed to the LLM. So this kind of tooling is obviously very important. But okay, that answer was not that great. Let's see if we can improve upon that. So I'm going to go in here and I'm going to use our command line client and have a bit of fun. And just create a function. So again, the command line client is something you can see on our page. And with a simple click, I've now created this get content function. So again, it's a DSL, now using it to create functions. And I can here. So a very simple function. It's called get content. We now return the content from a web page. And all we do is we need to have the URL for that web page to load. So now I need to hook it up to our agent. And for this, I can simply go here into Tools. And I can just simply say All Tools. So this is a new feature. So I can see the guys who know the Arc agent are like, what's that? This new feature. So usually you would list all the different kind of tools you want for that agent. But we're going to simplify that a little bit. So this is a magic kind of like feature you can use to include all the tools, all the functions that are available or running in the same server. So, okay, we're just going to click that. So as you can see here on the side, I'm making modifications to the file. And in real time, we are now reloading these files, which you can see in the right-hand corner. You can see the screen, so luckily it worked. And now let's replay what's happening here. You see it's taking a little longer. You can already see we have an LLM function called event, so it's calling the function. It's loading a lot of data. And now we have a lot better answer. So this answer is actually coming from the web page that it was previously providing us. It's picked out the elements that are used on the topic of AI. And that's basically it. So it looks good. I think I could probably ship it. So from here, all you need to do is now an Arc build, which will build this as a Docker container. And it can then be deployed anywhere on any kind of Kubernetes environment, or preferably on our LMOS environment. Okay, that was all I was going to give for an introduction. Thank you for listening. Yes, please.
So can you just explain what happened with the function? So
Yes.
yeah, like who makes the request? Is it local? Is there a server? Is there a service? And how does the scraping work?
So it basically starts off with here. So here, with this tools command, we are assigning this function to the LLM. So I could also write it as like this, get content, I think that's right, where we're just saying this is the function you can use. Now the way the functions work in LLMs is that each function needs a description. And based on this description, the LLM will decide whether this function needs to be called or not. And that's something that the LLM decides. When it decides that this function should be called, it gives us a message and says, please call this function with these parameters. So we have a little bit of boilerplate code on our side to map the response from the LLM to this function call. The function call gets called within our server. It's nothing magically that the LLM can call in itself, so it gets called. So here we're just using a HTTP GET function. So as this is a DSL, we like to keep things that are used quite commonly, very easily. So you can just write HTTP GET. And we are providing the URL that the LLM itself has provided us. Now if we look back at the LLM, or the system prompt, let's say, we can see here we're actually providing the LLM with the URL that it's meant to use. So it's not magically guessing what URL to use. We've actually told it to use this URL. But as you can see, without the function, it will return the URL itself. With the function, it will actually understand that it needs to fetch the content. So this is where it's clever, right? We're just telling it to fetch the content. We're not saying use an LLM function. We're saying fetch the content. And based on the description of the LLM function, it knows it needs to call this function with this URL, and that's how we get the response. Make sense?
Yes, I guess my question is more about who then makes the call, because the LLM finishes the generation of instructions.
Yes.
Then somebody else, it hands over to something that then makes the thing that you've implemented.
Yep.
And that then passes it back to something else, which is maybe the next LLM. I don't know. So that part, I guess that was more my question.
Okay, did I explain it, or do you want a bit more?
Yeah, for me, a bit more, unless I'm boring everybody else.
No, I think it's a good point, yeah. So it's quite simple, really. We send a request to the LLM. We say, here's all the data. So I think you can see that here. So we send the system prompt, all this data, plus we also send the description of the functions that it can use. That's a separate kind of like part of the method signature they provide us. As a response, we get a certain response from the LLM, which is saying function call. Please call this function with these parameters. Now it gives us the parameters in the form of JSON. So it's up to us, our client, so because this is a Spring Boot server, it's all running within the same instance, to interpret this response and to then make that HTTP call. So the HTTP call is happening within the same Spring Boot instance where our agent is hosted. And you can see then here, that's the callback. Can I see this here? Yeah, so you can see here, this is the function call event. So we're told by the LM to make this call. This is what we've loaded. This is the data we've loaded. And then we're providing this data now back to the LLM.
And when you say we, you mean LLMOS?
Yes, our Arc agent framework, or the client, yeah. So it's all one service, all one server.
Well, let's say Arc being a framework that runs on LLMOS.
Exactly.
Yeah.
Okay.
Yeah.
I would say later more about it. Usually we have a different order of talks.
But yeah, it's definitely a topic that I think a lot of people find hard to grasp. It's like, who's making this call? Is it really the LLM? No, it's actually us, the client, who is calling the LLM. We have to do all the heavy work and we're calling all these different functions as well. But luckily, all that is something you as an Arc agent developer do not need to worry about. You just provide the functions in this format and everything else we take care of. Okay, good question.